Hi, boys and girls. It's Miss Bissell. We are working today on lesson 14-4. We're continuing with topic 14, working with the coordinate grid, ordered pairs, and all that good stuff that we've been working on since last Friday. I need you to open your books to page 577. You will need a pencil and a straight edge of some sort. If you don't have a ruler, you can just fold a piece of paper up a couple times and create your own straight edge. All right, our goal today is on page 578. Our essential question will give us what we're going to be working on today. We're going to be solving mathematical problems using reasoning. So the question is, how can you use reasoning to solve mathematical problems? So we're definitely working with ordered pairs and the coordinate grid and putting information onto quadrant 1 of the coordinate plane in a line graph format and answering some real world questions. So back to page 577. Our scenario is that we have 6 clowns who apply for a circus job. The specific job requires the clown to have a clown shoe less than 15 inches and to be shorter than 5 feet 8 inches tall. The question is, how many clowns meet the size requirement for the job? Complete the graph below to help you decide. All right, let's go back and look. We need to see which clowns meet the requirement. So we want to know how many clowns meet the requirement. Going back, here it is. One thing is that they have to have a shoe size less than 15 inches, and the clown has to be shorter than 5 feet 8 inches tall. All right, so here's our information. We have the clown, we have their shoe size and their height. Don't forget, anything on the top row of a vertical data chart is an x-axis value or an x value, and anything in the bottom row is going to be your y-axis information or your y value in your ordered pair. All right, let's talk about this. We have Tippy, Yippy, Dippy, Zippy, Fippy, and Gippy. Oh, this is going to be a fun one. All right, so we have their shoe sizes. Let's take a look, and we have their height. So I look at my ordered pair. I look at my information on the graph. Clown shoe size, the X value here, clown height here. Somebody's already worked it. I love it. They actually did the double cut. They cut on the X and the Y axis to show you that even though they're using increments of 1 and increments of 2 inches, we have to start at 0. So they're acknowledging that they didn't forget data between 0 and size 12 shoe or between size 0 and 5 foot 0 inches. It's just that there is no data to plot there. We talked about that when we did line graphs. So this one's unique because we've cut both the X and Y axes to show that. All right, let's go ahead with Tippy. Tippy is at 15 for his shoe size and 5 foot 9 inches for his height. So we're going to start going on the X over to the 15 and then up to 5 foot 9. Now what I notice is I have 5'8" on this vertical line and 5'10". So we're going to put Tippy's right here. All right. And then we're going to look at Yippy. Yippy's shoe size is 13. His height is 5'10". So back to the origin, and we go over to 13, and we go up to 5 foot 10. All right. Dippy also has a shoe size of 13, but he is 5 foot 3. So he's going to go in the middle of 5'2" and 5'4". All right. Then we have Zippy, who has a size 16 shoe. Remember, we run on the X and then we jump on the Y, and we're going up to 5'2". So he's going to stop right here. And then we have Fippy, who we go over to the 12 and up to 5 foot 4. These names are killing me. Then we go to Gippy, who is size 16 shoe, 5'11" height. All right. So what I know is that, go back, these clowns that are qualified for the job have to have a shoe size less than 15 inches and be shorter than 5'8". Let's deal with the shoes less than 15 inches. So less than 15 inches would not include this one right here. This one is 15 inches. So you know what? Less than 15 inches. So I'm going to say that all these guys right here, anybody with a size 15, 16 shoe, these three right here, these have a shoe size that is too big for the job. So they can't be hired. Okay, shoe size is too big. Now the other qualification is that they have to be shorter than 5'8". So here is 5'8". So here would be the cutoff. Anything taller than that. So these guys right here are too tall for the job. Too tall. Okay. So what does that leave me? How many points? I see 2 points. So whoever was size 13 shoe and 5'3", 13 shoe and 5'3", that's going to be Dippy. I can put a little D there. And whoever was size 12 and 5'4", this right here would be Fippy. These names. All right, so 2 clowns would qualify for the job. So I'm going to make a note that only 2 clowns, and that would be Tippy and Fippy. Only 2 clowns, Dippy and Fippy, meet the requirements. Okay, so if you need to pause the video and look back over that, I could have written ordered pairs. I could have done, a 15 and a 5'9". I could have done ordered pairs, but we did this yesterday, so I did shortcut a little bit, thinking you guys could follow that. All right, the question at the bottom, using some reasoning, this is our special mathematician skill, is how can you use reasoning about the completed graph to find the number of clowns that meet the requirements? Explain. So what we did was we counted all the points that were to the left of 15 on the axis, on the x-axis, because those would be the clowns that had less than a size 15 shoe, right? And then we counted those that were less than 5'8", and that's how we found the points. So we just counted, right? We counted the points. So we count the points that are to the left of 15 on the x-axis and below 5'8" on the y-axis. Those were our criteria. They had to have a shoe size smaller than 15, and they had to be shorter than 5'8" tall. All right. I'm just going to remind you that when you're at home remote learning and you're watching my videos, you should be pausing them. And when you come back to school, what I have written down, you should have written down. Okay, if you were sitting in class with me, I'm teaching this lesson the same way to the boys and girls today, and they are writing down what I'm doing, okay? Because you can't learn just by watching the video. You've got to take these notes and have some problems that you yourself can look back at, okay? All right, let's go to the visual learning problem on page 578. Okay, we're going to continue using ordered pairs and the coordinate grid, and we're going to continue using reasoning with that to solve math problems. So in 1705, a ship sank in the ocean at the point shown. All right, right here it is, 0.46. Every year, the ocean currents move the ship 1 mile east and 2 miles north. Where was the ship located after 14 years? Where was the ship located after 10 years? Tell how you decided. All right, first of all, you guys know how to make a compass rose, okay? This is a directional graphic organizer. So You know the arrow pointing this way is north and opposite pointing down would be south. East and west are easily confused. West goes to the left and east goes to the right. And you know you have the compass arrow correct for east and west if it spells we. All right, if it spells oo, EW, it's not right. It's we. All right, so that's just a little quick tip on compass rose. All right, because I just started thinking you got to know directions to answer this problem successfully. All right, so what do I need to do to solve the problem? Well, we have to locate where the ship is after 4 years and after 10 years. All right, and how can you use reasoning? So these are the steps. We're going to use what we know about graphing points. We're going to graph some ordered pairs. We're going to look for relationships in the coordinates, and then we're going to decide if our answer makes sense. So this problem talks us through it. So this little girl helper says, I will use the graph right here to show the location each year for 4 years. Each point is 1 mile east and 2 miles north from the previous point. All right, so what they did was they went 1 mile over and 2 miles north. Okay, 1 mile over, 2 miles north, 1 mile over, 2 miles north, and when I say over, they're going east, 1 mile east, 2 miles north. Okay, so they have graphed right here the ordered pairs. So the first point is where we had the ship located originally. All right, the second point, 5, 8, comes because we went to the east 1 and we went to the north 2, and we ended up, that ordered pair right here between 4 and 6 is 5, and right here 8. All right, then we went east 1 mile, north 2, and we look at that ordered pair, 6, 10. All right, and so on. So these are the points, okay? So after 4 years, where was the point? So here's where we started. Here's year 1, year 2, year 3, year 4. So we end up at 814. So that is the answer to the first part of the question. All right. After 4 years, the ship was at 814. All right. There's a pattern going on here. The x-coordinate increases by 1 and the y-coordinate increases by 2. Look at all these ordered pairs. From 4 to 5 to 6 to 7 to 8, only focusing on the x-coordinate in the ordered pair, do you see that it increases by 1? Okay. Now, the y-coordinate, 6 to 8 to 10 to 12 to 14, only focusing on the y-coordinate, increases by 2. All right. So we can continue the pattern for another 6 years. After 814, we would get to 916. We would add another 1 and 2 to what we have to get 1018. We'd add another 1 to 10 to get 11, add 2 to 18 to get 20, add 1 to 11 to get 12, and add 2 to 20 to get 22, and just continue that pattern. So after 10 years, here is where the ship would be at 1426. Okay? After 1 year, it's going to be at 814, and after 4 years, 814, and after 6 years, it's going to be at 1426. Okay? Now, to decide if your answer makes sense, okay, what you're going to do is, if you know that the ship is shifting east and then north of where it started, and that's the direction it goes, then the ship should be east and north of where it sank. So look at 814, your first answer. 814, is it east and north? Yes, so that could make sense. Excuse me. All right. And after 10 years, the ship should be east and north of where it was after 4 years. So if it is at 814 after 4 years, is the next 1416 going to be east and north? And if it could continue, yes, it would be up here somewhere, right? So it does make sense. All right, let's try another one. All right, so Tanya marked a grid in her garden. She planted a rose bush at 3-1. All right. She moved 2 feet east and 1 foot north and planted the second rose bush. She continued planting rose bushes. so that each bush is 2 foot east and 1 foot north of the previous bush. All right, so how can the coordinate grid help you reason about the problem? Well, what are we going to do on the coordinate grid? We're going to start with our beginning point, which is the ordered pair 3, 1. So let's start at 3, 1. And we can mark it like they did in our example problem on page 578. So here's our first start point. All right, so can't we just then plot the points on the coordinate grid to show the locations of the rose bush following the pattern? All right, so we're going to use the coordinate grid, and what we're going to do is you can plot the points on a coordinate grid, and we're going to abbreviate coordinates. There you go, coordinate grid, to show the locations of the rose bushes. We're going to show the locations. Of the rose bush. Okay. So let's go for it. So if the first one is at 3, 1, and what we have going on is from this point, we move 2 feet east and 1 foot north. What I noticed is each horizontal and vertical line are increments of 1. They've just labeled every 2 just to give some space there. So let's do this. We're going to go over on the x-axis 2 feet east. So 1, 2, and we're going to go 1 foot north. And this would be where the second rose bush would be. And that ordered pair is 5, 2. Okay. Next, we're going to go from this point. We're going to go 2 east. We go over, and then we go up 1. And we're going to plot this one at 7, 5. All right, and then from this point, we're going to go over 2 and up 1, and this rose bush will be located at, 9, 4. And then we're going to go over 2 to the east, up 1 to the north. This rose bush is going to be at 11, 5. All right, so we have the original one, and then we've got a second one, third, fourth, fifth. All right. Now, here's the question. We were supposed to draw and label the locations of the first 4 bushes on the grid. Oh, I did 5. What the heck? Do Tanya's bushes lie in a straight line? What do you think? All right, let's check. If we can draw a line through them and they all are on my line, then yes. So let me get my line through here. Oops. I have my straight edge. I don't know if you can see it. There we go. All right, there's my line. So all the points are on the line. It's not like there's a point over there, right? They're all on the line. So the answer is yes, the bushes do lie in a straight line. And how do I know it? Well, a line can be drawn through the ordered pairs that represent the locations of the rose bushes. And that worked, right? So a line can be drawn through the ordered pairs. All right. And then the question was, what are the locations of the 5th and the 9th rose bushes? So I know what the 5th one is because I see it here, but let me show you something. Let's just jot down right here a data table. And let's do our x-axis value and our y-axis right here. So what we did was we started at 3, 1. So my ordered pair, the x value was 3, the y was 1. I'm actually going to take the ordered pairs and put them back in a data chart. Yesterday we took the data chart and we made the numbers into ordered pairs. So we're kind of working back. The second value was 5, 2. So this was the start point, or the first bush, right? This was the second. This is the third. And that one, the rule was we add 2 to the x because on the x we're going over 2 miles. we're going up 1 on the y. So I'm going to kind of put my rule up here, just get all my information. That helps me because then I have 7, 5. No, 7, 3. All right. Then my fourth bush is located at, add 2, make sure it was at 9, 4. It was. And then my fifth, I'm just kind of looking at the rule and then checking it. My fifth should be, if I follow the rule, at 11, 5. And yes, it is. So the fifth bush, we were correct, is at 11, 5. Now we're looking for what? The ninth? So if we extended it, we'd have 6, 7, 8, and 9. This is when I wish we had more space in our books. So this one would go up 2. So we'd have 13, 15, 17, 19. All right. We extend 1 each time for the y value. So I have 19, 9, and 11, 5, right? So I have the fifth bush at 11, 5. If the pattern continues where we add 2 to the x value, and I know we're adding 2 because we're going 2 feet east, so that represents right here on the x-axis. I know the y is plus 1 because we're going 1 foot north, okay? So 19, 9 is where we would be. So the ninth bush would be at 19, 9, okay? All right. I'm going to do this one right here real quick, and then I'm going to wrap it up. So this one has a marching band that uses a grid to determine the members' positions. We have one who's going to start at 2, 2. Every 15 seconds, he's going to move 4 yards east and 3 yards north. So take a look at what they've set up for us. So the x-axis is east, the y-axis is north. He's starting at 2, 2. So if we're going to model this problem, the way that I'm going to do it is I'm going to draw the points on the coordinate grid to represent his locations. So I will draw points on the coordinate grid to represent his positions. That would be a good way to model it. All right. So draw and label the locations of his first 4 positions. So we're going to start there. So he starts at 2, 2. So we're going to go over 2. Remember, we start at the origin. We move over on the x-axis and up on the y. A fun little way to remember where to go is start at the origin and you run on the x before you jump on the y. So 2, 2 is going to put us right here. 2, 2. All right. Now, his next point, I got to go back and see what the rule is. So the rule says, or what it says happens every 15 seconds, he moves 4 yards east and 3 yards north. So 4 yards east, each one is a yard, looking at my increments. So 1, 2, 3, 4 east. And how many north? 3. 1, 2, 3. So his second point is located at 6, 5. And I know it's 5 because it's halfway between 4 and 6. All right, the third point, again, I'm moving 4 yards east and 3 yards north. 1, 2, 3, 4. 1, 2, 3. And that puts me at 10, 8. All right, and then what I'm supposed to do is next position, 4 positions. So let's move over. 1, 2, 3, 4. Up 1, 2, 3. All right, and that's going to put him at, what's that, 14, 11. Okay, so I've modeled his points starting at 2, 2 and following what it says. His constant move pattern is 4 yards east, so 4 yards on the x-axis and 3 north, so 3 on the y-axis. So we drew and labeled the first 4 positions, and the question is, do the points form a line? So let's look. Do these points form a line? Absolutely. All right. Yep, straight line. So the answer is yes. And boys and girls, it should form a straight line. If we have a constant pattern, which we do, 4 to the right, 3 up, 4 to the right, 3 up, then it should create a straight line. If we have a point not on that line, we've made a mistake when we've graphed or plotted our points. So yes, a line can be drawn through the 4 points. So that is how we know that we have a pattern. When it asks, do the points form a pattern? How do you know? Yes, because a line can be drawn through the 4 points. All right, what will Juan's position be after 60 seconds or 90 seconds? How does the coordinate grid help you reason about the location? So he's moving every 15 seconds. So here he starts, so 15, 30, all right, what's this going to be? 45 seconds. So we're looking for where he'll be next. So I'm not opposed at all to taking it down to some kind of a data chart and plugging in my points. So let's do this. Let's do the X value and then the Y. We learned when we make a data chart, it's not going to be anything fancy. So I'm going to just make a little area right there. I'm sorry, it's a little sloppy. So this is going to be at 15 or 0 seconds, start point 15, because it's every 15 seconds, 30, 45. All right, so if we have at 45 seconds, if we have one at 1411, and the rule is add 4 as you move along the x-axis east and add 3 as you move along the y. Just stuck my rule out to the side. I'm just going to look at where I would be every 15 seconds. So that's 45. 15 seconds more would put me at 60 seconds. I add 4 and get 18. I add 3 to 11 and get 14. So 18, 14 is going to be one of my answers, right? Now the next one, what, 60 seconds to 90? So I could do 75 or 60, 75 seconds would be 15 seconds more than 60. Add 4, 22. Add 3, 17. All right, 75 plus 15 would put us at 90 seconds right here. I'm sorry, I'm crammed in. Add 4, that puts us at 26. And add 3, that puts us at 20. So right there are my locations of Juan crammed in there after 60 and 90 seconds. I just plotted the information in a table so I could extend it and find his location. So at 60 seconds, Juan's going to be at 18, that's the X value, 14. And at 90 seconds, he's going to be standing at 26, 20, using my ordered pairs that I created by extending the graph. All right, so we have worked on using reasoning to solve mathematical problems that deal with ordered pairs and graphing. You notice that we even went back and have reviewed, using a line graph, because this line graph is taking place in our quadrant 1 of the Cartesian coordinate plane. So your homework is going to be a boom card activity. I put it in instead of doing practice buddy 14-4. I looked at the practice buddy. I didn't really like it. I thought that it was a little confusing. And so I found a really good set of boom cards that had some good questions that just kind of review all the concepts, the basic stuff we've been working on. So your goal for me is to finish the boom cards. You also need to be making sure that if you're an AA student, you should be working on your last 2 week 7 spiral review, weekly review problems. If you're a BB day student, you should be working on it 2 a day so that you're done and ready to give me that when you come back on Wednesday. All right, I hope everybody has a wonderful weekend. If you're on early, don't forget at 9:15 I am going to do a Google Meet for those of you that want to practice some multiplication with a 1-digit multiplier. At 10:15 I am going to be on Google Meet if you want to practice division with a 1-digit divisor. So at 11, I've got to be off because we have a meeting with all the 5th grade parents. Mr. Hoots has set up meetings with each grade level, kind of to do a live Google Meet with your parents to answer any questions, kind of to share what's going on. And So I will be with your parents from 11 to 12. And if your parents can't make it, Mr. Hoots is going to video the meeting, and they will be welcome to access it. I'm sure he'll tell us how they can get a hold of it. All right, so have a great day, and I will talk to you later.